Good afternoon. I'm Hussein Awa, and I'll be presenting to you my project, which is titled VoIP and the Mobile IPTV Client on the LTVC platform. And before I start, I want to thank my supervisor, Mr. Nico Ventura, and my second marker, Dr. Olisa Flower, and everyone else who could take time out of their busy schedule to come listen to my presentation. So, the flow of my presentation is going to be modeled after my report, so I'll try to highlight the main aspects of every section of my report. So I'll start off with the objectives and the scope, which are closely linked to the project title and the terms of reference. That will be followed by the literature and research which are carried out and the related work which has already been done in these fields, which I'll be working with. Then after that, I'll go to the design, which is the architecture which I decided to settle on, and I might give motivative factors as to why I chose this design, and maybe talk a little bit about the intricate details about the design. Then from there, the results which were gathered from the application which was developed, and I'll discuss a little bit about this and what it implies, and then I'll move on to the conclusion as to what was finally achieved in this project. So the objectives of this project, as the title clearly says, would be to develop a voice over IP or an IPTV client. But these services have already been existing for a while. So what this entails means I'll have to see what does this architecture look like now, and how does it run on a 3G network, and what would be needed to change, what do we need to change to make this architecture more compatible with the LTE on EPC platform. And the next thing which I want to do, which is more like the implementative objective, would be to implement a voice over IP client. Normally I would have to do an IPTV client as well, but because of time constraint, I settled to doing just voice, because voice in terms of communication has more implications. And I try to define my scope to limit me only to that. And this client is going to be able to register the user on the network, make and receive calls on the LTE platform. There will be no video or instant messaging on this platform. So my literature review, I decided to model my research based on the different architectures which have been developed for multimedia transmission. And the most prevalent is the all SIP architecture. And in this architecture, it uses only SIP for session initiation and session control. It uses SIP again for media control and media setup on the trick function and all that. The second approach which is used is a blend on a hybrid of SIP, which stands for session initiation protocol, and RCSP, which is real-time session protocol. And it uses SIP for session initiation and control, and then it uses RCSP, which is more suited for real-time transmission. It uses it for the real-time, for the packets control and the other things. And in the course of my research, I decided to look at different implementations which have been done to achieve this, either a voice over IP or an IPTV client. And the ones which are most common, which are open source, was I looked at the IMS Droid, I looked at SIP Droid, I looked at SIP Simple, and I looked at the UCT IMS client. And all these different implementations had their pros and cons, but the one which I found most interesting and most related to my project was the UCT IMS client. And this is because it was designed to work on a 4G architecture, an LTE EPC architecture. But the drawback with this implementation is the fact that it was done in C, and most Android applications have been designed to work with the Java environment. So I would have to work around that to get it working. And so I settled, as I mentioned earlier, the two architectures which were used were either all SIP or a hybrid of SIP and RCSP. I decided to settle on an all SIP architecture because it is easier to implement in the sense that it is text-based, and it is closely linked to other protocols which are used on the internet. And if you look at, this is what it looks like. You have the agents, all transactions go through the proxy server, and then the users register on the registrar over there, and then the transactions go through there. And in terms of my application, I did the user interface in Java. So all transactions go through the SIP stack, which I implemented in C, in native C, and then this SIP stack interacts with the network, the responses go back through the C native environment and back to your response come back in Java. So in order to achieve this, I had to use the Android native development kit, which helps embed a C development environment into a Java environment, which was based on, so that's why I mentioned the UCTMS client, which was done in C. So I used that to adapt it to the Java environment. And in terms of my results, due to the fact that SIP is a request and response kind of protocol, what I had to test was based on the fact that can this client successfully send requests to the network, and can the network receive this request, understand it properly, and send back a response to the client, and the client can implement that. So I used Wireshark, which is a software used for packet tracing, and you can easily analyze it, which was installed on the EPDG, which is the Evolved Packet Data Gateway. And from there I could analyze the packets which had been moving through the network. And for this example, we see that the user with this IP address, let's call her Alice, sends a register message, as you can see from here, to that registrar. And if you look at the data unit here, level session instruction protocol, it's clearly formed and well formed. It says register from there, and that's the user agent which is sending that. So this is a request which is being sent, and this is what the response looks like. This is the response from the server, which is saying, okay, I have received your request to register, but I want to be sure that you're actually a user. So it challenges the user and gives some information which has to be authenticated, and then once the user completes that, it can register on the network. And so this was the same model which was used to perform the other functions, like making a call, which is simply an invite message, ending a session, which is a buy message, and other stuff like, and other things like that. And so to conclude, this is what the application looked like. I could show you on the phone, but probably wouldn't see it clearly. And so the implementative objectives was to design a VoIP application, which was successfully done, and it was able to register, establish sessions, and end sessions on the LTE-PC client. And in terms of my recommendations, the fact that I didn't have enough time, I didn't implement a complete SIP stack, so it couldn't do things like notify of events and subscribe. So for future work, this could be added to the service, and you could add internet instant messaging. And secondary goal of this project was to do IPTV functionality. This could easily be added to this project because SIP is an agnostic protocol. It doesn't pay much attention to what is actually transmitted within it. So whether it's video or voice, it could easily be incorporated into SIP, and you could easily do the IPTV functionality. So that is just to round up with my project, and I'd like to hear if you have any questions.
Any questions?
If you want to extend this project to cover video applications, what do you need to add to this particular design?
Okay, so the way the SIP works is it's kind of a broad protocol, and within the SIP you have the SDP, which is a session description protocol, and within this you kind of describes whatever you're carrying. So within the SDP, if it's audio, the parameters which you set for the SDP protocol would specify its audio, and if it's video, the parameters of that SDP within the SIP would specify it's for video. So right now I did the one just for audio. So it will just simply mean that when you're sending the SIP message for a video, the SDP message, the message part of your protocol, is going to contain video data instead of audio. And this could be extended to do data transmission and anything. So that's what makes SIP widely used in this field.
Thank you. How scalable is this design? How many voice sessions can you support at the same time?
At the moment, this is it's suited just for one session, but it could also be extended to include more users and more sessions. Yeah. Because the architecture that I based it on, the UCTIMS client, it actually supports multiple users. But because I was scaling it down to make it easier to implement in the short time I had, so I had to take out most of the stuff. So easier if I could take the whole UCT IMS client, it would be fully functional with all of that.
Any other questions? Okay, just as an aside to focus on your presentation, was there or wasn't there a way of you showing the workings of the connection or the registration of the client to on the terminal? Because you showed us an Android app window. Wasn't it possible for you to show us that yes, there's something that could show an established session or something like that, or a video or something?
Established session.
Because at this point, you showed the wiretap, your Wireshark keys.
Yeah.
You showed that you could actually see
A
messages that show
yeah.
establishment of
Registration.
But now, yeah, the question that remains is, could you actually establish that from
a session
from your mobile client?
from my mobile client
From the client on
my phone.
yeah.
Oh, okay, yeah.
Because if you had something like a video maybe that could show, I've transmitted something and here it comes through,
It
or
shows,
you know,
yeah.
something that establishes the functionality of your entire system while also showing the working of your little application on the phone.
Yeah, on the phone. Yeah, I just didn't think of that. I just thought maybe I should have focused on the results. But yeah, I actually think about that, yeah.
Okay. Any other questions? Thank you.
Okay, thank you.